multidisciplinary， 就是台湾人中国讲的就是跨领域。所以 today's talk is about a different way. So first we welcome the Dr. Lee from Korea. He's right now is the president of APPS and the APSU, and Dr. Lee will give about how to build a smart hospital. Dr. Lee, please.
Thank you very much. Actually, this topic is not very academic, and it is good for the young urologist, but not good for the old urologist. So, so please enjoy the lecture. So today my topic is smart care of prostate cancer patients using IoT and AI. Actually, now I got a new position of president of Smart Hospital in Seoul St. Mary's Hospital, is one of the vice president of our hospital. So we had the opening ceremony of a Smart Hospital with our Catholic father. They can decide everything. So actually, the Smart Hospital built on the ICT environment of interconnected asset. But the important thing is aim. Aim is definitely improving patient outcome, treatment outcome, and patient convenience. So now we call this a big data revolution. So in young urologists, they have to know the AI or big data and post-industrial evolution. Otherwise, they cannot survive in near future. So in our hospital, now we are focused on the mobile pay and telemedicine and virtual rehabilitation. And especially in this time, I'm focused on the voice EMR and biotelemetry with using smart band. And everybody's doing the precision medicine and robotic surgery, and then AI. But why prostate cancer in urology? Everybody knows the RCC is internist tumor. So intern can see the tumor mass in the CT scan, and treatment is very easy, surgical removal, even metastatic cases. And then if they metastasis, the survival rate is very low. How about prostate cancer? Ultrasound and CT scan, we cannot find out the tumor, and even MRI, we need expert prostate radiologist. Only 60 and 80% can detect by MRI. More dark and less dark, we cannot find out where is the tumor. How about the pathology? Gleason score is very important. Some hospitals send the patient Gleason 7 and they recommend the surgery, but our pathologists say this is Gleason score 6, so I recommended active surveillance, and then the patient is confusing. So treatment is depend on the age, life expectancy, and stage and Gleason score. And even organ-confined disease, there are so many treatment options: active surveillance, focal therapy, nerve sparing, robotic prostatectomy, cyberknife, proton therapy. Yesterday, Professor Suzuki told about the carbon particle therapy. So we don't know which is the best treatment for which patient. And then, you know, the RCT or large-scale observation study, we need a big money and long time, more than 10 to 15 years. So we need AI. So if you want to smart aftercare prostate cancer using IoT and AI, we have to make a clinical database, biobanking, and genomic database, pathologic image banking, radiologic image banking, and then we can do the AI, deep learning. So I set up the prostate bank from 2007, now is 12 years experience, and we made a clinical database and specimen storage in the biobank, and then micro dissection. If you get the genomic data all put together, and then we can make big data, bioinformatics. Also, we can put in the imaging data, pathology and radiology. What is the clinical unmet need for the prostate cancer? in clinical database, we need the CDSS, Clinical Decision Supporting System. Imaging, we need the MRI, 3 Tesla MRI, so automatically PIRAD scoring. How about Gleason scoring is also very important. So this is a prostatectomy specimen. So even pathologists cannot distinguish where is the tumor area. After microscopic examination, they can draw like this. Oh, this is a tumor and this is the tumor. So we set up the Korean Prostate Bank from 2011, and last year I started the government AI project. The 8 hospital has different AI project. My Seoul St. Mary's Hospital is main project is prostate cancer. So I called the name of this AI project is Promise Clip, the Prostate Medical Intelligence System Enterprise and clinical data, imaging data, and pathologic data. So after 3 years, we can combining this clinical imaging pathologic data just one click. So we started last year. We started the cleansing data and imaging deep learning and pathologic deep learning. So Korean company Buno is very excellent venture company for imaging data. So they started deep learning of 3 Tesla MRI imaging. You know that it's very difficult to get the whole MRI imaging matching with the pathologic imaging. So we have a 700 matching imaging. So we started the deep learning technique. Digital pathology is a Korean company, Deep Bio. They are digital pathology company only focus on prostate cancer, and they got the second, the world contest second prize. And then the clinical data, the Liposemantics company is doing that. So we already visualization of clinical data, and then we have to multi-center EMR system. So we made a pre-processing software to extract the text data and standardization of this kind of thing. So using Liposemantics and PIRAD score prediction, the MRI. This is a Buno company, and this is a pathology company. So they already automatic diagnosis cancer area, 97 to 99%. So we digital scanning of whole biopsy specimen, 400 degree, and then they can detect the Gleason score, and then 7 pathologists is consensus for Gleason scoring. So more than 5, they agree. We can call this as a Gleason pattern 3, or the orange color is 4 and red color is 5. So I think we can make a new Gleason scoring system. Just 3 plus 4 is all same in our pathologic staging. So 3 is 92% and 4 is 8%. Sometimes 3 is 72%, 4 is 25%, and 3 is 52%, and 4 is 32%, and 5 is 16%. So every these cases I think is different. So in the future we can match with the clinical data and oncology outcome with this new Gleason scoring system. We can make a new scoring system. So this company is only focused on the prostate pathology only. So I think it's good for their company. How about the metastatic hormone-sensitive prostate cancer? Androgen deprivation therapy is the standard treatment. And then the urologists don't care about the patient quality of life. Bone health, muscle health, sexual health, cardiovascular event. So everybody knows the hormonal therapy decrease cancer-specific mortality, but increase cardiovascular mortality. So we know the exercise can reduce the cardiovascular mortality, especially supervised personal training. So I think IoT-based mobile lifestyle intervention is just like a supervised exercise. So I started a government mHealth project, Smart Aftercare, using the smart band, prostate cancer. And then we can give them everything, general management, medication, and even we can give them a movie clip, and then they can do the exercise in their home base. So my conclusion is we include whole prostate cancer patient, but it is good for the hormone treatment prostate cancer patient, but it's also not very effective for the prostatectomy case. So it's great effect only for ADT. So we plan to randomize clinical trial for hormone patient. So last year ASCO meeting, we present the internet-based and mobile-based lifestyle intervention for prostate cancer, especially hormonal treatment patient, prospective multicenter randomized trial. And then smart care patient 100, a conventional exercise 100. We concluded the exercise is useful for treatment or relief of adverse effect of hormone treatment prostate cancer patient. And especially smart aftercare service is effective method of prostate cancer patient improving exercise capacity and general health related quality of life. So I think smart aftercare service maybe improve the overall survival in the near future. How about the medical tourism? So in the 9/11 terror, the medical tour is impossible in the United States, in Arabian people. So there are so many Arabian people visit Korea. I think the Taiwan is also same. And Russia is the medical service system is totally broken. So Vladivostok and Khabarovsk is very close to Korea, just 2-hour flight from the Incheon. So I have many Russian patients also. They visited for the Korea, just sightseeing visa because Russia blocking the medical tourism in that area. So the number of foreign patients in Korea 2009 is just 60,000. But now it's 300,000, more than 300,000. So increasing very rapidly. But the problem is oncology is different from the plastic surgery or something. So oncology patients need long-term hospital stay and technical advance for treatment, and after care, rehabilitation, and long-term follow. It is a hurdle for medical tourism for uro-oncology, I think. So we made a one-stop service for foreign patients, PSA, MRI, biopsy, interpretation just one day, and then multidisciplinary decision-making for IMRT or robotic surgery or hormone therapy. So every Tuesday morning we have a good urologic oncology team meeting with medical oncology, radiation oncology, radiologist, pathologist, everything. And then we have 3 robotic Xi machine and IMRT and many good instruments. But problem is recovery and rehabilitation. They cannot come too easily to visit Korea. So I set up the telemedicine system to overcome the distance. So I set up the telemedicine system from Abu Dhabi and our hospital. So she is a leukemia patient and bone marrow transplantation in our hospital. And then she cannot come to Korea again. So I set up the telemedicine system to Abu Dhabi and our hospital. And 2017, I also had a Mongolian telemedicine system. It's a government project. So he is a vice minister of health and welfare in Korea. So I'm here, and then MOU with Korea and Mongolism for telemedicine system. He is the president of the first Mongolian hospital and our Catholic Seoul St. Mary's Hospital. So MOU together, and we started the telemedicine system. And he is the cardiac surgery in my hospital, and then he is a cardiac surgeon, pediatric cardiac surgeon, and pediatric cardiologist consulting with the telemedicine. And I also made a telemedicine system in Hebron, Cambodia. So if you know the AI or big data or something like that, you can survive. But otherwise, you have to retire earlier than your expectation. So I usually visit many hospitals because I have to learn new technique and new techniques. So MSKCC last year, so I saw the Dr. Befa's MRI guided HIFU, and I also visited the Juntendo Hospital. Professor Shigeo Horie invited me to live surgery in 3 days, 4 cases, kidney and prostate. And then Professor Zhang is here, but 2016 Taiwan Neuro-Oncology Society meeting, and Professor Chen invited me the Rector Forum last year. And this year we had, last year we had the APPS meeting in Maui, Hawaii, conjoining with the Western section of WEIE, and the president of Western section AUA told me they want to do every year conjoining meeting. So you can see Dr. O is here, and this year is Shanghai, the December 6th to 8th, and you can see the Professor Zhang. He will host the 2020 APPS meeting in Taiwan. So last year we enjoyed the dinner here. So thank you very much for your attention. Thank you.
Thank you for your excellent speech. Now open to discussion. Any? No question? Because the topic is too big. I think nobody can decide everything. Okay, we next to the one.
Thank you very much for the wonderful talk. May I ask one question? Yeah. So you guys have so sophisticated system to do the telemedical system and also user IT to combine all the data and AI and everything is so sophisticated. So how long does it take to construct all these things, and how was the initiation of this construct? When did you decide to this concept? What was your motivation or initial thought of this setting?
It's a very difficult question. Actually, I started this project just to get the government fund. Because I need a fund to have a research. But I found recently government fund is changing to basic research to the IoT-based research. So now the 50% of our government fund is focused on this kind of thing. So I changed my research. Actually, the research has a trend. When I was a student, everybody doing the immunology, antigen antibody, right? And then PCR, and then the stem cell, and then genomic. So we are the clinician. We have to use the many things. We cannot focus on antigen antibody forever, right? So my research is changing every time. So now is IoT-based AI.
So when was the first time to apply for the grant? When was it? When was the time when you first time to apply grant for IoT?
It's a smart aftercare for 2015.
2015?
Yeah.
Only 4 years?
4 years.
Only? Wow.
At that time, I'm just beginner.
Wow. Thank you very much.
Okay, thank you, Dr. Lee. We move to next.
The next speaker is the other AI expert from Taiwan, Dr. Chang-Fu. Now he is the division, the attending physician of the division of rheumatologists in Linkou Chang'an Memorial Hospital. Also, now he is the director of the Big Data Center in Linkou Chang'an Memorial Hospital. So we welcome Dr. Ku.
Thank you very much for inviting me to this symposium to talk about the AI. And now my topic is integration of neural network and deep learning in clinical practice. And I will share with you some of AI basics and also a new AI application in clinical practice, and also some of the novel way to practice AI medicine. And in fact, AI is not a very new idea. It has been devised in 1950s, and it is a computer specialty technique to simulate human capacity. And what can the AI do to improve human capability? It can help us about cognition, learning, problem solving, and language. And the machine learning is just a kind of algorithm, and to help us to achieve the goal of artificial intelligence. There are many type of algorithms, such as deep learning or CNN, RNN. That is not important for doctors, but is very important for engineers. We need to provide our domain knowledge and apply AI algorithm to do something in clinical practice. And deep learning is just an algorithm. It is just like a logistic regression or cost regression we often use in clinical research. And it is better than regression models because it is more versatile, and it can enable deeper extraction of hidden information in the data, and also allow heterogeneous unstructured data. Now what we call big data, we often refer to the structured data, and many other kinds of data types, such as image, is unstructured data, and that is very difficult for a computer to handle this kind of data and make prediction. And if we use the deep learning algorithm, we can achieve the handling of unstructured data. However, we need to use a very big computation power. The deep learning is a kind of very complex web of computation, and just like this one. For example, if we want to recognize a human face and to know the identity of this image, we need to go through the input the image through a very complex neural networks, and each connection is a parameter. So the neural network uses a lot of vast amount of parameters to describe the image and to make prediction. How many parameters on average for a good neural network? Millions of parameters. So for an average logistic or cost regression, we do not use over hundreds of parameters, because that will cause a problem we call overfitting. But if we use a deep learning, we often use millions of parameters to describe data. There are many kinds of difficult jargon vocabulary in this field. If you want to know more, you need to know the supervised learning, unsupervised learning, neural network, and deep neural network. Also, several other kinds of jargons. But for a clinician, we need to know how to apply AI in clinical practice rather than to know the very detail of these technical problems. Why is this AI very popular and very important in this year? We can see that we call it ImageNet. ImageNet is a collection of over 14 million nature images collected from the web. And in the past, in 2010, it started to make a big competition, allow computer algorithms to do predictions, and it had 1,000 different kinds of categories. It is very difficult for traditional method to predict 1,000 category of images. And for humans, the accuracy of recognize 14 million image is around 95%. But after 2015, the accuracy of computer vision algorithm based on deep learning is over human accuracy. Now the accuracy last year, 2018, the accuracy is over 97%. That is for computer vision problem. The accuracy of deep learning has already surpassed human capability. So what do we need to develop an AI algorithm? We need a large amount of high quality data, and we need effective annotation. And now we also need computation power and modeling framework, and then we need domain knowledge and testing ground. So for a medical application, we have four aspects that we can participate in the development of algorithm. We have data, we have annotation because doctors make the diagnosis, and we have domain knowledge. We know how to apply this algorithm, and we have hospitals or clinics to do the testing. Next, I will share with you some of the application of AI in medicine and biology. There are three types of different questions that AI or deep learning can do. The first one is the disease and patient categorization. For example, make a diagnosis from an image, make a classification from a radiology, or fundamental biology study and treatment of patients. There are several approved applications, but these approved applications are always simple algorithms, and I'll share with you that. And the first one I want to share with you is a typical scenario. It's just to identify or classify patient based on a lung CT. This paper is published in the Lancet Respiratory Medicine, and this study tried to recognize idiopathic pulmonary fibrosis using a high resolution lung CT. And the accuracy in fact is not very good. We can see the accuracy 77% to 85%. But for IPF, the accuracy of human diagnosis is always in this area and in this range. And we can see the cost regression model and the survival curve. We can see that the predictive power of AI algorithm is very similar to human experts. This study is very famous study from Google, and it used an AI algorithm, computer vision algorithm, to diagnose diabetic retinopathy, and we can see the ROC curve. This is it's a very impressive ROC curve. It's almost 98 to 99% accuracy rate, and it has surpassed the average human doctor to diagnose diabetic retinopathy. That is why last year FDA has approved this algorithm to make diagnosis on its own without human intervention. And another one is digital pathology and related work. This is also from Google, and this study used AI algorithm to detect micrometastasis of breast cancer in lymph nodes. And this is a very difficult work because for a typical digital pathology slide, there are 200 million pixels in a digital pathology images, and which is tenfold larger than typical digital images. And we can see that for negative, it's a real world practice, and for a negative lymph node or a macrometastatic lymph node, the accuracy is no different. But for micrometastasis slice, AI assisted methods is surpass pathology capability to make a diagnosis. This is another study from Google using the same algorithm to do Gleason scoring, and you can see that the accuracy is very similar, and the prediction of survival is very similar based on AI algorithm and pathologists. This is I think this is one of the most important application. This is very easy, It use the AI algorithm to detect malaria procedure so this is very important work to assist malaria prevention in the Western Africa. Another one is the AI for breast cancer HER2 status, and we can see that in the real world comparison for 71 cases, AI and pathology had 55 cases which is concordant and 12 discordant cases. But after a further review, AI algorithm have more accurate diagnosis than pathology panel. This is one of the applications which has been approved by FDA last year. And this algorithm is a very simple algorithm to detect a small fracture in the wrist. And so it just uses a plain film to see whether there's a fracture in the wrist, and it has been approved last year in May. And another application which has been approved is we call AI Doc. This one is to automatic detection of acute brain hemorrhage using brain CT, and it also has capability to integrate into PACS and to do rapid triage. And this one is also approved by FDA. There are also some other applications which have been approved, and I will show you later. I will not go into very detailed of fundamental biology process because the replication of biological process for AI there are many different kinds of process, and it's very difficult. And for example, this one we use this study was published in Science, and it used an algorithm to find disease causing variants and to classify this variant into several different groups, which can predict autism or cancer or spinal muscular atrophy. Another one is more like a tool. This one it also comes from Google, and this one we call Big Variant, and it's an AI genomic tool. It can greatly improve the annotation and the variant coding with very good accuracy, and this one is better than current best practice from GATK4. Another category of AI application is the treating disease and to developing a new treatment. And there are many different kinds of applications, and not everything is approved by the FDA. But I think many more applications will come in the next few years. For example, for drug development, it is very important to see whether a small molecule can adhere to a protein and to prevent or augment the function of this protein. And in the traditionally we need to test the molecule and using the wet lab approach, and it is very time consuming. Now we can use a so-called in silico prediction, and this one has been proposed by the Atom using AI algorithm. If you can screen thousands or even thousands or tens of thousands molecules in a single prediction, that will accelerate the drug design very much. Another groundbreaking algorithm also from Google, and we call it the AlphaFold. Why is it very, very important? Because this is from DeepMind, and it can predict 3D protein structure from peptide sequence alone. And traditionally, we need to use a crystallography to do the protein structures, and now you can use in silico prediction to do this. That is very, very important for drug development. And another one is we saw we use hospital electronic record and prediction. We can use the rolling prediction to see whether a patient will have intrahospital mortality or any unplanned admission. So from clinical aspect, we can see the comparison of performance. This one is come from a new paper from Nature Medicine, and we can see there are many different categories of application from radiology, pathology, dermatology, ophthalmology, and gastroenterology. And in general, the performance is at least on par with human efforts. And because AI will not get tired, so AI algorithm generally has a better consistency. And another one, we can see the prediction accuracy from many categories. We can see that, for example, for in-hospital mortality, the AUC from 75% to 93%. And in this category, we can see variable accuracy, but generally, this prediction accuracy is better than traditional methods, such as using cross regression or logistic regression, and always better than human expert prediction. These are the applications that has been approved by FDA last year, and there are two categories. One is for computer vision, and another one is electrophysiology. In fact, only one electrophysiology application has been approved. That is the Apple Watch, and the others are all are computer vision, such as to use CT to detect brain hemorrhage, or something like echo to detect to predict ejection fraction. However, in my point of view, I agree with this paper that AI will integrate into not only into clinical practice, but in the entire process of healthcare, from the embryo selection in there's an application to make a better embryo selection for IVF, and then to avoid medical coach, and also mental health, to paramedics, to diagnosis, and to make prediction. So I think in the next few years, there will be many more AI applications in the clinical practice. We need to prepare for that. And for hospital, we have many different kinds of data, and this data using an AI algorithm, we can make a better prediction for patients. And this is the core of personal precision medicine. So we need to understand how to use this AI empowered application, but I think we don't need to very worry about that. For example, several years ago, we do not have a smartphone, and now everyone uses smartphone, and you don't need to learn how to use smartphone. In fact, many applications from smartphone has been AI empowered, and you don't even notice that. For example, face recognition. Face recognition is a very typical AI technology, but nowadays you won't see AI for face recognition. So I believe in the future, maybe in 1 or 2 years, AI will be part of our many software for medical application, and we may spend a little time to learn how to use this application better, but we don't need to very worry about that. Another one is we doctors, we need to invest some time to help the development of AI algorithm. And I think this is a very great opportunity for all of us, because we have data, we have domain knowledge, and if we have a good collaboration with engineers, we can jointly develop very good software to help our clinical practice. Thank you very much.
And a question.
Thank you for your nice lecture. It was a really wonderful lecture. I'm from South Korea, Saksubyun from South Korea. My question is about the obtaining pattern right in this field. Right now, we can see a lot of artificial intelligence algorithm is applying to make clinical application. So, can you give me information about the United States, the Patent and Trademark Office's viewpoint?
Patent is And in fact, patent is not very important in the AI area because most AI algorithm or platforms has been open sourced. And for example, for Google, the very famous framework for AI development is TensorFlow is open source, and many other applications also open source. I think in this area, patent is not important, but you need to very quick to make a application and get approved from the authority. Another big barrier to prevent your competitor is data. You have data and you have open source platform and technology, and you can develop everything you need. I think in last year the FDA has issued a new guideline for AI application and their approval process, and that is very quick. Their concern is not how advanced of the AI application, but they concern about the safety of the AI application. So I think if you have a very good algorithm, just publish it online and get the base intact, and later you need to get enough data to build the application and send it to the FDA.
I have one question that because we all are clinicians, how especially for a young doctor, how to if you want to join the AI, what do they need? Because in the genetic era we needed to learn the PCR or something like that, and then in this era we needed to study this or algorithm and so on.
In fact, AI is in the fundamental of AI is very mathematics, but we doctors do not know much about mathematics. We do not need to learn very details of this application, but we need to know how to use this modeling process. And if you want to join this area, the best way is to go to the AI school. From academia sinica, and now I'm a student, and I feel that is very good. And you spend 16 weeks. That's enough for a doctor to involve.
Most next speech. Okay. Now it's corporate